Hey guys, how's everyone doing? First video that you're gonna see from me, not the first video I've made, but the first video you're gonna see from me, just summarizing the notes from last Thursday of the ChiSquare Goodness of Fit test in case anyone was absent for it. So they are posted online. I just wanna kind of give you some things just to pay attention to. So I'm gonna read through the problem. In his book Outliers, Malcolm Gladwell suggests that a hockey player's birth month has a big influence on his chance to make it to the highest levels of the game. Specifically, since January 1 is the cutoff date for youth hockey leagues in Canada, where many National Hockey League players come from, players born in January will be competing against players up to 12 months younger. The older players tend to be bigger, stronger, and more coordinated, and hence get more playing time, more coaching, and have a better chance of being successful. To see if birth date is related to success, judged by whether a player makes it into the NHL, a random sample of 80 NHL players from the 2009-2010 season was selected and their birthdays were recorded. Overall, 32 were in the first quarter of the year, 20 in the second quarter, 16 in the third quarter, and 12 in the fourth quarter. Do these data provide convincing evidence that the birthdays of NHL players are not uniformly distributed throughout the year? Speaking of hockey players, I have two of my favorite hockey players right here that want to come say hi real quick. This is...
Yes. I'm Anders Opal. I'm Monica Opal.
And you'll see them occasionally from time to time in the videos that I made. They're great students. They give me a great audience. So it's like I'm not just teaching to a screen. I have some kids here listening to me and participating.
Yep.
So they're going to take off right now because I'm going to just quick explain this.
Bye, guys.
But,
bye, guys.
Yeah, they're going to go play in the living room or do something else. I don't know. So, okay, guys, here we go. So there's a little pre-work sometimes with a Goodness of Fit test. And that pre-work is sometimes you do need to make a table if one was not given. So what we did here is we said, okay, what was going on? What was the category that we're talking about? And we're talking about the quarters of the month that hockey players were born. So there's the first quarter, the second quarter, the third quarter, and the fourth quarter. And then we have to say, well, what did we observe about it? So we wrote those numbers here. 32 were born in the first, 20 in the second, 16 in the third, and 12 in the fourth. Okay, we're going to leave this expected. I'll explain where this all came from here in a second. But we go with the state. And so in the state, we need our null and our alternative hypothesis. And then we also need our alpha level. For a chi-square Goodness of Fit test, our null hypothesis is always going to talk about the distribution being what the claim is or what it should be, okay? And then the alternative hypothesis, the HA, should always be what you're trying to prove, okay? You're trying to prove that it's not what it should be, okay? So here we have the null hypothesis. The distribution of birthdays are uniformly distributed throughout the year. HA, the distribution of birthdays, is not uniformly distributed throughout the year. And I talked a lot about how I really like to stay consistent with all my chi-square tests. The HO, the null, is always an is statement. The HA is always an is not statement. Now, sometimes I also talked about it's helpful to, if you're curious on how to phrase it, to look at the question. So, do these data provide convincing evidence that the birthdays of NHL players are not uniformly distributed? Okay, we want convincing evidence always for the HA, okay? So here's my HA, the birthdays of NHL players are not uniformly distributed. That's my is not statement. So then you just change the null to an is statement. We assume that they are, okay, uniformly distributed. And here is the notes that I put in there. Now the plan, I joked, is we're not going to go in a RIN, we're not going to go in a PRIN, but we're going to keep it real. Okay, we're keeping it real in AP Stats. So what does real mean? R is still random. We have a random sample of N is equal to 80. Our independence stays the same. That 10 times N has to be less than capital N. Now there's hockey players in my classes, and this is a big debate that there's not 800, right? Or there's not more than 800 NHL players. And I said, let's just assume that this is everyone who signed a contract. They maybe didn't make it onto the team, but they are owned by that NHL franchise. I think that's right. I'm a hockey person, but not that much of one. So we're going to say we're good to go. And now the L means we need a large enough expected count, okay? So your expected count must be greater than 5. So this is where I talk about what should happen if the null is true. This N times P, don't worry about that right now. That comes into play later. So we go up to make this expected. And I should say, you guys, I'm talking fast. I'm trying to kind of just crank these out for you because I know what it's like watching a video and it's not always fun sitting there and watching a video. Okay, so if at any chance you're like, whoa, she's talking too fast, first off, feel free to email me to slow down a little bit. But also, you know, I don't have a class here. I'm not doing my labs. I'm not checking in with you. I'm not asking you questions. So just make sure that you pause things, you're rewinding things, and be writing things down. And I have discussions everywhere. So post questions or whatever comes up, okay? I think my kids are wrestling in the living room, so forgive me if you can hear them, okay? Just try to tune it out, hopefully. Okay, all right. So back to the expected count. So this is what should happen if the null is true. So the distribution of birthdays are uniformly distributed throughout the year. So I talked about, hey, we have 80 total hockey players. Then we should expect them to be 20, 20, 20, and 20 across. And then we talked about, hey, look at what we observed. There's some big differences, especially with that 32 in the first quarter and that 20, okay? Some pretty big differences there. So what does that mean? So we go through our expected counts. They are greater than 5. You do need to state C table above, okay? And we're ready for our method, our chi-square goodness of fit test. And now we're on to the do part, do the do. And we talked about where to find that. And I think I still have it up. I do. Okay, so that chi-square statistic. Give me 1 second. I'm gonna take a little. Okay, so we have that chi-square statistic right now. The sum of the observed minus the expected squared divided by the expected. So I go back, right? And I look and I say, all right, my chi-squared, my first thing I observed was there's 32 players in the first month or first quarter, right? And we can go back and look at that right there. That's what we observed. And then we have to subtract the expected from it, square it, and divide by the expected. So I do that throughout, and you can see if you have it all written down, 20 minus 20 squared, 16 minus 20 squared, so on and so forth. And we get 11.2. The degrees of freedom are the number of categories minus 1, okay, and that's equal to 3. And then we talked about how to do this by hand, by actually calculating each piece out, adding it, we get that 11.2, and then we go to that table, right? And we have to figure out what that p-value is. So I go to the chi-square, 3 degrees of freedom. I scroll over, it was 11.2. So 11.2 is in between 9.84 and 11.34. I scroll up and I say my p-value is between 0.01 and 0.02, okay? So that's where that came from. I also then showed people how to use the calculator. Now, if you have the older calculator, it will not run the test for you, unfortunately. If you have the newer calculator, I want you to practice that on your own and then submit anything. I'll just kind of quickly show you. I don't think I have any data in there to help you out. Oh, I do. Excuse me. I have the same data from class. So we have L1 is our observed. L2 is our what should happen, our expected. And then we go to stat. We arrow over to tests. And we have a goodness of fit test. Now, if you have the older calculator, you don't have a goodness of fit test. So you'll have to do it by hand or check on a link that I'll be posting later and you can write a program for your calculator. I don't think it takes that long. I don't think the AP is going to give you like 12 different things to calculate because they're assuming that you can do this without a graphing calculator, right? That you can do everything just with a little calculator. So I go to stats, I go to chi-square goodness of fit test, I hit enter, my L1 is my observed, my L2 is my expected, and I have my degrees of freedom. And I go down and I calculate. And there we go. So there's our p-value, 0.0107. That's our actual p-value. And these CNTRB, those are our contributions. So you can see this value right here is 7.2. This value right here is 0. This value here is 0.8. And this value here is 3.2. And that's important that you know what those contributions are for follow-up questions. So I'll show you what that means in a second. All right, so finally we get to conclude. Let me just write down what we did here. Okay, so we found the chi-square statistic, we showed our work, we found our p-value with our degrees of freedom, okay, talking about it being the number of categories minus 1, and then here's what we got on that test. So because our p-value is approximately 0.0107, which is less than alpha 0.05, we reject the null hypothesis. We have evidence the distributions of birthdays is not uniformly distributed throughout the year. Okay, now what I was talking about with that contribution, so sometimes there's a follow-up analysis and it's talking about the contribution, like what individual component contributed the most to this chi-square value. And in this case, January contributed the most to the chi-square. More players were from January. I shouldn't say January, forgive me you guys, not January, the first quarter. So that would be January through March. More players in the NHL were from the first quarter than we expected them to. And that was really what contributed to that high chi-square value. Okay. All right, lastly, just in closing, we then quickly talked about the first problem from your homework about that mixed nuts. And the reason we did that is because it's a little bit different in the fact that they give us percentages of what should happen, okay? So in a batch of deluxe mixed nuts, 52% of them should be cashews, 27% almonds, so on and so forth, okay? And so we talked about what the null hypothesis, again, the company's distribution of type of nuts is correct. The company's distribution of type of nuts isn't correct, okay? Now, the big thing was, well, how do I find the expected? Because it's not just saying like the hockey players where we took 80 and we did 20, 20, 20. We take our total sample, our N, so that's 150 nuts, times 0.52, okay? And we should get 78. And then we do it again here, 150 times 0.27, we should get 40.5. So that's just another way to find expected. If you have any questions, just let me know. I'm out of breath. I said so much. I completely miss you guys so much. I love being your teacher, and I hope I get to see you guys again soon. I will be setting up some conferences through Schoology so we can have some discussions, just live time as well. So take care, you guys. Hang in there, and we will all get through this together. Stay positive.